this lesson, I would like to talk with you about a very important principle in software development, and this principle is called the single responsibility pattern. Single responsibility pattern. Does anybody have an idea what single responsibility pattern could mean? Uh-huh. Exactly. A method should only do one exact thing and not 3 and 4 and 5 things. Otherwise, if you have multiple things to do, you need multiple methods. Okay. Other people don't call it the single responsibility pattern, but the anti-pattern is the spaghetti code pattern. Spaghetti code means that a method does all at once. It is the user interface, it does data access, it does business logic. It's like a big chunk of spaghetti and spaghetti sauce and parmigiano and whatever. So this is exactly what we don't want. And this is what we are going to talk about. Now, if we take a look at the code that we have written in the morning, I think it was that one, the spell checker. What would you say? Does this fulfill the requirements of a single responsibility pattern? So could we clearly identify the task that spell check does? I don't think so. If we take a look what spell check does, the first thing is it reads the dictionary from a file. It gets the file name from configuration settings. It splits the dictionary in multiple pieces. It splits the sentence in multiple pieces. It walks through all the words and checks whether it's in the dictionary, and at the end it returns all words that are not in the dictionary. So it is spaghetti code. Because we have a user interface here. The user interface in this case is a web API. A web API is also a user interface. It's for a user, in this case a programmer, but programmers are also users. We have user interface, we have I/O, interface input/output, and we have some business logic. For instance, this could be business logic, this could be considered business logic, and everything mingled into one single method. Any suggestions what we can do to improve the situation? What could we, for instance, extract out into separate methods if we want to fulfill the single responsibility pattern?
The file reading stuff.
The file reading stuff. Okay, so the file reading stuff could be this one, right? Good. So let's refactor that out. And now I have a tip for you. C# Visual Studio is super helpful in this regards. You have this screwdriver here on the left-hand side. It's the so-called Quick Actions tooltip. If you click on it, you will get an action which says extract method. We can just click on it, and with it will automatically extract the method into a separate function, and we just have to enter the name. So what does this method do? How should we name this method?
Read dictionary.
Read dictionary, I agree. Read dictionary, and a small addition to that. If a method is an asynchronous method, and this is the case because we have async await, the method name should end with the word async. So please call it read dictionary async. That's just a naming convention. You don't absolutely need to do that. Your code will not break if you don't do it, but it's let's say a good habit for a professional C# developer to call async methods async something. Good. Now if we fold it up, you will see that the system, that Visual Studio has automatically extracted it into a separate function, and it was pretty smart doing that. It automatically recognized that it is an async function because we have an await in here somewhere. It recognized that it should return a task and all these things. So, pretty useful. Extract into method. Good. Looks good. I'm happy with that. Any suggestions? What else could we do? What else could we take out of the spell check function?
The split part.
The split part. Can you tell me a line number? Which one would you suggest? You can't see the line numbers because it's like this. So is it better?
Yeah.
Do you mean the first one or the second one? The reason, the first one. The first one could be possible because we have this replace stuff and we have this split stuff. It's already pretty short. You are right. We could do that, but I would prefer a different place. Do you have another idea?
Both. So also not what, so that the method is called twice. So if once with the string and \n and the second time. So basically a better split version which also replaces.
Okay, but the problem is we only need a replacement once because there we don't have a replacement.
Is it a problem if it's replaced?
Yes, because we are doing something which is unnecessary and therefore we are wasting CPU time.
Okay.
Yeah. What do you think if I would suggest that we could maybe think about this stuff here? This stuff here is kind of checking which words are in the dictionary and returning a list of words that we found that are not in the dictionary. I think this would really be a good candidate for extracting it out into a separate method because it's a longer piece of code, it's a more complex piece of code. We have a loop, we have an if statement. Would you agree that this could maybe make sense? Can we do that? Do you follow? Okay, good. So let's try this one. I think it's from a point of view of describing the concept, it's a good way to do it. Bless you. So let's take the screwdriver again and extract the method. And how should we call the method? Give me a second. Any suggestions for the method call? Name, method name?
Compare words. Compare
words.
Something like that.
Compare words. Good, I follow your suggestions. You wanted to make a comment or
Yes,
a question?
What if I use the short form of this code?
The short form of this. The single line. Then you have to extract the single line into a separate method. So you were asking, I showed you in the morning, I showed you that you can do something like this. So we had return sentence words dot where word goes to not dictionary contains words. Essentially we had this one, right? In that case, you can take this one up until here, use the screwdriver and say extract method. Your method will be pretty short. It's just a one-liner, but that's fine. That's not the point here, okay? So this is what you could do if you have the short form. So I don't mind if you use the short or the long version. I will stick with the long version, but the things that we want to discuss are really exactly the same. So now let me do it again for the long version. I am marking this code using the screwdriver, extracting it, and I think we said compare words, right?
Yes.
Okay, good. Nice. Wrong. I did something wrong. Please select this part. Did you just select this one or this one? Okay, if you selected this one, this part, just follow along in your mind looking at what I do. I will do a mistake, a conscious mistake. I will do this one and we'll say compare words. The problem here, if we do something like this, is that this isn't really beautiful code. Because if I take a look at this method now, compare words, this method compare words gets on the one hand side already nicely chopped dictionary. So a dictionary which is chopped into parts and where I get every single word. But the other parameter gives me a whole sentence. What I have here is another pattern that you should avoid when writing beautiful code. You should avoid a code where you have different levels of abstraction. Here you have the ready-made dictionary words. Here you get something which has to be splitted. Get the idea? So if you cut the functions like this, I don't like that, because one of the split mechanisms are outside here and the other split mechanism is inside. See that one? So you are mixing the levels of abstraction, and this is not good coding style. So what we do is we split the sentence into word and keep it outside. Get the idea? Then we can give it the already splitted words, and now I like this method. So if you did it correctly from the beginning, you did it well, I made a mistake, and now we discussed whether this is not very beautiful. Now, let's continue talking about this method. In C#, this means an array. You all know a C# array, right? Good. What will be an alternative to a C# array? A list. We could use a list of string, right? Now, is it a good idea to use a string array as a parameter here when it comes to compare words, when it comes to a parameter to a method? Or do you have a better idea of a different data type that we should use? IEnumerable of string. I agree. Why would it be better to use IEnumerable of string? Let me edit here. Compared to string array. Why is that better? Imagine the caller of the method has a list. He wants to call your method, but your method requires an array. What do I have to do? I have to copy the items from the list into an array, and that's unnecessary. But the nice thing is that IEnumerable, so just a collection, generally a collection which I can read through, this is compatible with array and with list. So the caller isn't forced to use an array. The caller can use a list or an array or whatever implements an IEnumerable. Understand what I mean? So generally, the rule is expect the least specific type that you can handle. Least specific means the most generic type. And IEnumerable is a very generic type. It just says I need to be able to read through the parameters. I don't care whether it's an array. I don't care whether it's on the heap. I don't care whether it's on the stack. That's not perfectly correct what I'm saying here. I don't care whether it's an array or a list. Let's put it that way. IEnumerable of string. And we do the same here. IEnumerable of string. This is the rule for nice code, IEnumerable. For nice clean coding. Always expect the least specific type, the most generic type, to put it that way. Yep?
We can also replace the string with a generic template.
This one?
Yeah. So instead of string, generic for all the string.
I'm not sure, because we have the contains function here. Okay. The contains function is an extension method. Yeah, you are right, we could do that, but that's not my point. Would be possible, but that's not the road that I want to go now. Yeah, you're right, we could. You're absolutely right, but I don't want to do that now. What about the resulting type? This is more important now. What about the result? Is it a good idea to return list of string, or should we also go back to IEnumerable of string?
IEnumerable because it's not diverse and can be used for lists as well.
Yes, but now your argument is turned against you, because the rule is we should return the most specific type that we can guarantee. The problem with our current implementation is that we give definitely back a list. And if we at some point in the future, maybe in a month, in 2 months, in 3 months, we are taking a look at the algorithm and we say, we shouldn't have used a list here. We should have used an array here because then our algorithm is more optimal. But the problem is we return a list, right? And if we change the resulting type, we will, take a look at here, we will break the user. See that one? If we change this from list of string to array of string, then the user of our function will get an error. And in many cases, the user of the function are not we ourselves. Maybe we are responsible for this function here, and a colleague of us is responsible of using this function. And then we are breaking his code by changing the return type. Do you know what I mean? So the reason for this, or the reason that we can derive from that, is return the most specific type that you can deliver on the long term. It's a kind of contract. I'm signing a contract. Dear caller, I guarantee you that I will always return a list. I will never return something else. And I must not change my mind. You know what I mean? If you are in control of the calling side and the callee side, so the implementer of the method, and you call the method yourself, it's just an internal method. I don't care. You can change and break your code however you want because, well, if you break code, you have to fix the broken code because it's your code. You know what I mean? But if you work together in a team and the user of your code is different from the creator of your code, you want to be a good citizen. Otherwise, the users of your code will not be happy with you. And therefore, it's not a good idea to return list of string here. So with that in mind, if we want to stay generic, we can also change that to IEnumerable, but not because we don't have something more specific, but just because we don't want to make promises that we can't hold. Another option would be iList. There is an interface, iList. There is another interface which is called, or not an interface, another class which is called collection. But in our case, it's perfectly fine that we return an IEnumerable and change that one. Now I'm happy with this. So these two principles aren't super important. For instance, at the exam, if you do a wrong thing here, I will not shout at you. That's not the problem. It was important for me that we extract that in a separate method because this was really not beautiful. Having this whole business logic code inside the controller code, that was not beautiful. That thing that we discussed now is more a further beautification of our code. We should do it, but yeah. The world doesn't end. You are not jumping over a cliff if you make a mistake here. If you are Microsoft and you are designing APIs for hundreds of thousands of developers, you should really think about before you break code, because you break code for hundreds of thousands of developers. But if you are just breaking code for a colleague that sits across the table and you know this colleague, then it shouldn't be a problem. Good. Nice. Now take a look at this spell check method here. Now it looks much nicer. It consists of 3 different tasks. Let's restructure it a little bit. Let's pull this split up here. Split dictionary and sentence into words. Yeah, now I like it. We do a little bit of reading. We do a little bit of splitting. We do a little bit of comparing, and then we are done. That's good. Yeah, I can live with that one. That is meant with all the lines of code should be on the same abstraction level. You shouldn't have a single line of code doing all the reading, then you have very detailed algorithmic stuff with loops and ifs, a long piece of code, and at the end you are just calling a large method again that does the rest. It's like a book where one of the heroes is introduced in 3 sentences, and then you have 3 chapters introducing the second hero, and then you have another 1 sentence where you introduce the third hero. That wouldn't feel balanced, you know what I mean? It should be on the same abstraction level, and this is exactly what we want to have here. And now this looks much cleaner and much better. I like that. Good? Good. The next thing that I would like to discuss is what we can continue to do with our read dictionary and our compare words. Because in reality, in larger applications, your business logic is typically not that trivial. Your business logic is typically much more complex, okay? And therefore, it's a good practice to split your application even more into parts. So what we want to do is we want to dedicate a complete class to the task of reading the dictionary from the file. Okay? This is what we want to do. And this is what I would like to do together with you. How are we going to do that? We call such utility classes so-called services. Okay? Therefore, we add a folder, and we call this folder services. Not services in terms of web services. This is just a service that we are going to use inside of our application. Think of a pizzeria. The service of a pizzeria is to serve you pizza. The service of a Chinese restaurant is to serve you a good fried rice. This is a kind of service we are talking about. And we want to build a class whose service it is to read a dictionary from a file. Got it? Good. Not that difficult. Let's add a new class. Right-click on services, add class. How could we call this class?
File reader utility or something.
Okay, file reader utility. I like the fact that you are using the word reader here because that is a noun and class Hauptwort. That classes should typically be called with a noun. Reader, writer, button, document. Understand what I mean? While functions are typically called like a verb. Get, read, write, store, close, open. You get the idea, right? So classes, nouns, methods, verbs. Good? So in this case, I like the word reader. But I don't like the word utility. It's too generic. How would you, if somebody reads file reader utility, would this somebody understand that you are reading a dictionary? Not really. So dictionary reader, I like that one. So dictionary reader, and we don't need the word utility. It doesn't add value. Good, dictionary reader. I'm still not happy with this name. We can rename it a little bit because yes, it's a dictionary reader, but where does it read the dictionary from? A file, right? What do you say if I would suggest that we rename this file to a dictionary file reader? Would that be okay for you? Because it reads a dictionary from a file. Dictionary file reader. Good. I like that one. Now let's move the method read dictionary async from our controller into the reader because the controller is our user interface. And according to the single responsibility pattern, our user interface shouldn't be responsible for our business logic. So therefore, let's cut this thing out and move it into the dictionary file reader. Now we are missing a using statement here with the file not found exception. That's simple to add. And then we have a problem. We have two problems, to be more specific. Here, we need our configuration system. And here, we need the logger, right? How do we get the logger into the read dictionary async method, and how do we get the configuration system into the method? Well, we can make a parameter, right? I would suggest that. Let's try that. So what we can do is we can take, I think I have it somewhere here. Yeah, I configuration and I logger. We had it here. Bang, just a parameter and we are good. Of course, we need some usings. Use the light bulb and go. And go. Good. Good. Ah yeah, we have to make it public. Looks good, right? Yeah. We can access the configuration. We can access the logger. It's not quite what we want to have. We will just see that we just solved one problem, but we opened another problem, but one step after the other. I will wait a few moments until you have changed your code accordingly. Did you make the changes? Good. So let's go back to the controller. Our big problem now is that we can't use read dictionary async here anymore. Well, it's not that big of a problem. Let's fix it. Var reader equals to new dictionary, dictionary file reader. Good. This is the class that we just created, and then we say reader dot, and then we pass in the config and the logger. Right? Hooray, it works. But doesn't it feel kind of awkward? From the point of view of the controller, are we really interested in this configuration stuff? Do we need anything from this configuration stuff? The only thing we do is we are passing it on to the reader. You understand what I mean? It's like if you go to the pizzeria and you have to bring your own salt and your own flour and your own tomatoes and your own cheese and pass it on to the cook in order for him to prepare the meal. You don't want to do that. You just want to go there and say, I want a pizza, and that's it. I just want to have a dictionary file reader, and I would like to say, read this dictionary for me. I am not interested in what you need for that. Do you understand the problem? This is not a good design what we currently have. So what we want to have, we want to get rid of this config stuff and this logger stuff. Any suggestions how we could do that? How did we do it in the spell check controller? We created a constructor, right? Let's try to apply the same principle. So I ask you to copy the constructor of the spell check controller stuff and copy it to the dictionary file reader. Something like this. Of course, we have to change it here. Good. If we have done that, we can delete the parameters here. So I will wait until you have changed your code accordingly. I copied this stuff. I changed the name of the constructor. And I have removed the parameters here. Could you follow along? Nice. Our dictionary file reader, yoo-hoo, is already done. It works perfectly fine, but now we have a problem here in the spell checker. Because we have only just moved our problem. Now we don't have to specify the configure and the logger here, but now we have to move this stuff up into the constructor. And that doesn't really make sense. We have just shifted our problem. We haven't solved it. Good? Now what could we do? Conceptually, we could do the following. We could say we need somebody else. We need some kind of central registry. A central piece of code where everybody who offers a service can go to and say, I am capable of offering a dictionary reader service. And if somebody needs a dictionary reader service, that somebody can also go to this dictionary and says, I need a dictionary reader service. And the same is true for configuration management. If I need configuration management, somebody, in this case ASP.NET, registers this service and somebody else can say, give me this service. Same is true for logging. Somebody registers the service, somebody else gets the service. So we have kind of, let me quickly draw that here on the screen because then we have it on the video. We have an internal registry. On the one hand side, services are added. These are the offers. And on the other hand, if somebody needs a service, he goes here and gets the services from here. And here in the middle, we have a list of services and somebody has to fill this stuff. You know what I mean? This is called dependency injection. Maybe you can remember from last year from Angular and TypeScript, there I also told you that we have something that is called dependency injection. We had this HTTP client stuff in TypeScript and so on. Maybe you can remember how that worked, right? Very similar here. Dependency injection is everywhere. And dependency injection in C# works as follows. Please follow along. Trust me for the next 2 or 3 minutes and then we will discuss why it is like it is. Please add in the services folder a new class, well not really a class, it will become an interface, and we call it an dictionary reader. Please note that I didn't call it dictionary file reader, I just called it dictionary reader. Why did I call it dictionary reader? Because it's an abstraction. There could be an iDatabase dictionary reader. There could be an iDictionary downloader from internet. You know what I mean? There could be an iBuffered reader, which offers some caching mechanism in order to not always on and on and on read the dictionary from file. It could cache the dictionary for a few minutes and only check every few minutes if the dictionary has changed. You know what I mean? We can have many different dictionary readers. And then when we register our dictionary reader at the central repository, we can decide whether we want to have a database reader or a file reader or whatever reader we want. This is why I'm using the word dictionary reader and not iFile dictionary reader. Let's add the interface. Interface. Could you describe what an interface is? You have probably worked with interfaces in C#, in C++, maybe also in C#, maybe also in Java. We have definitely worked with interfaces together in TypeScript. Could you describe what an interface is? Yeah?
A description of a class.
A description of a class? That's a little bit too few information. It's not just a description of the class. You have an idea? A what? Ah, okay, yeah, I like that. I like that also, but I would like to combine both descriptions. You said it's a description of the class, and you said it's a mandatory list of functions that a class must offer. And this is really what an interface is. An interface is a guarantee that a class offers at least, and this was missing in your description, offers at least these functionalities. The class might offer more, but it offers at least this functionality. Okay? So what we can do is we can go to our dictionary file reader, copy the signature of the method, this one, copy it to the iDictionary reader, so we can specify every dictionary reader has to offer a method read dictionary async, and this method will return a task of string. And now that we have defined what an iDictionary reader is, we can go here to the class and say, yes, my dictionary file reader is capable of doing all the things that an iDictionary reader must be able to do. Do you get the idea? If I do something, if I do a mistake, for instance, if I just call it read dict async, boom, things will break because we are no longer a valid iDictionary reader. Can you remember in TypeScript I told you something about duck typing or structural subtyping, all this stuff? Very similar to this. There are differences between TypeScript and C#, but we will not talk about the details here. Good? Good. So now we have an iDictionary reader and an implementation. How does that help? Well, it helps a little bit. What we can now do is we can say we would like to be independent of a single implementation. We would like to say iDictionary reader here. That's pretty abstract, and I would like to spend a little bit of time talking about what we are doing here. Please take a look at this line. This line says, I want to have a dictionary file reader. So I want to have a dictionary reader that reads the dictionary from file. I don't want to read it from a database, and I don't want to have any caching. I just want a file reader. But on the left-hand side, we are limiting ourselves to an iDictionary reader. So we don't program with all the features of the file reader. We go one abstraction level above and say, from here on, we are just limiting ourselves to everything that the iDictionary reader can do. So theoretically, if we would like to read the dictionary from a database, all we have to do is we have to change this with, for instance, DB, like a dictionary DB reader. Okay, of course we have to implement it. But I think you get the point, right? And the rest of the code, it's the same. Because the DB reader is also an iDictionary reader. They are compatible. Got it? Good. Nice. This is still not dependency injection. Because who is responsible of deciding whether we want to use a file reader or database reader? It's the spell check controller. And we don't want the spell check controller to be responsible. Now let me show you how we fix that. That's the last step. And then we have the full picture, and we can try to apply this picture in a few areas. So I go to the startup class here, startup, and then I go to the configure services method, and this configure services method is now this kind of registry. I can add classes to dependency injection, and from there it will be taken. Let's write the code. It's just a single line. Services.add transient of iDictionary reader, dictionary, file reader. What we are saying here, we are saying, hey ASP.NET, if somebody asks for an iDictionary reader, I decide that I would like to use the file reader. Not a database reader, not a caching reader, but exactly the file reader. If anybody asks for this iDictionary reader, this is what we want to use. Do you get the idea? And finally, we can fix our controller. Now we have all the tools necessary to fix the controller, because we do the following steps. Because now we have registered the iDictionary reader, we can now ask for the iDictionary reader directly here in the constructor. Just like the iConfiguration, just like the iLogger, now we can ask for the iDictionary reader. I will call it reader. Let's save it for further use. And remove the new dictionary file reader here. We don't need this one anymore. So let me mark what I changed. I added the iDictionary reader here. I save the iDictionary reader here in a variable, that's this one, and I have removed here the line where we explicitly create the dictionary reader. I will wait until you change your code accordingly. And see what our nice friend Visual Studio does. Visual Studio tells me, hey Rainer, in this class, in the spell check controller, you don't use the configuration system anymore. Why? Well, that's the salt with my pizzeria. We don't need to bring the salt anymore. Everybody is getting the services from the central service repository, from this dependency injection container. So we now don't need to know, we don't care longer for the configuration system. We can just remove this guy. We can remove the config here. We simply don't need it anymore. We don't need to bring our own ingredients to the pizzeria because the iDictionary reader, the dictionary file reader can get it himself. Come on. Ah, nice. Good. So let's give it a try. I think we had, was it spell check? Yes, I think this was it. And let's see, it still works. So we didn't break anything. That's a good thing. That's exactly what I wanted to show you. So let's quickly summarize and then we will do a very short break. What did we do step by step? First, we put the dictionary reading in a separate function. Because we have the principle, single responsibility pattern, we put it into a separate function. But this was not enough. We don't want to mix one class, spell check controller, the user interface, API, and the business logic and I/O, reading of the file for the dictionary. We don't want to mix that in a single class. So we created a new class, this one, the dictionary file reader. Then we created an abstraction, the iDictionary reader, and finally we added the iDictionary reader to the central repository of application services by using this add transient function. I will describe what the transient means in a second, but I think this was pretty heavy stuff. So I think we should make a short break. I know we wouldn't have a break now, but I think 5 minutes is good. I think this week's goal is to go out. So if you want, take a short walk. We'll do 5 minutes. In 5 minutes, I will continue. Maybe want to take a coffee or whatever. Okay? Short break.
Ist die wirklich so klar? Das ist die gerne.
Ja. Und dann ist der Stein so. Der Stein so. Der Stein so. Du wieder. Und bleibt klar.
Genauso oft diese.
Ja.
Genauso oft.
Mhm. Geht's der Maturaball-Vorbereitung? Ja. Stressig? Das gehört dazu.
Deswegen sind sie ja schon
Gut. Ja. Good. I hope that helped to get a little bit of fresh air into the body and the brain. I think that helps. Good. Let's continue and let's redo that for another piece of logic in our application. But first, no, not first. Let's redo that. So in the spell check controller, we have done that with the read dictionary method, and now we here have a method which we called compare words. And I would like to recap exactly what we did, but now I want you to tell me what to do. I will perform the steps, but yeah, what is the first step that we have to do in order to factor out this method into a separate class and make it available using dependency injection? What do we have to do? Good?
Create a new class.
Create a new class. Good, I agree to that. In the services, we say add a new class. How should we call the class? The method was called compare words, I think, right? Yes, compare words. So how should we call the class? Word comparer, I would suggest. I don't know if I'm really not sure if it's a word.
In Java, class is called comparator.
Oh, really?
Yeah.
Oh, you see, I have never used Java. So let's call it word comparer or word comparator. I don't care, whatever. It is a class. I'm happy with it. Good. Next one. Move the method. I agree. So let's go to the spell check controller and move the method. Good. Move it here. I agree. Make it public, otherwise it isn't accessible. Oh, we have a logger. We need a logger, but we don't have a logger. What do we do? Yep.
Add it in the constructor.
Add it in the constructor. Just a quick recap. If you want to have a constructor, CTOR tab. And you get a constructor. Right? We need a logger, no problem. We already know that from today's morning lesson. I logger of word comparer logger. Looks good. Add the using and save the value for future use. This.logger equals to logger. And again, Visual Studio is super convenient. I can just press Control dot and say, generate the field for me. See it? Again, Visual Studio is very polite because it tells me, hey Rainer, I have these 4 dots here. I have a tip for you. You did something wrong. And if we take a look here, the read-only modifier is missing. Good. I like that. So we can compile the word comparer. Next one.
Create an interface iWord comparer or something.
Okay. We create an interface iWord comparer. By the way, it is not absolutely necessary to create an interface. It is best practice, but please don't do what I do now because it's only half beautiful, but it's theoretically possible. What we can do is we can say services.addTransient and we can say word comparer, something like this. So we say if somebody asks for a word comparer, give him the word comparer. That's somehow not beautiful. Theoretically, it's okay, but I definitely prefer the way that you suggested. So let's create an interface. How could we call this interface? iWord comparer. Some people try to be funny with this I stuff and they don't call these things iWord comparer. They call it I compare words. Yeah, if you prefer that, whatever. Would you mind closing the door? It's a little bit loud outside. That's helpful. Thank you very much. So we have an interface, iWord comparer. And what should be inside of this interface?
The compare words method.
Good. So let's go to the word comparer and copy the signature of the method and put it into the interface. I would like to show you something where Visual Studio helps you a lot. Please take a look at the video beamer. That saves you a lot of typing. What I did is I kept the I word comparer interface empty. See that one? But what I did, I already marked the word comparer as an I word comparer. Now I have to copy this method into the interface. And guess what? You don't have to do that manually. What I can do, I can use the screwdriver here, Control dot, and then it offers me the possibility to pull compare word up to I word comparer. So all I need to do is I need to Control dot, pull, enter, and what I immediately get is the correct method here in the interface. Nice, isn't it? Good. Now I have an interface, I word comparer, and I have an implementation, word comparer. What is the next step that I have to do? I already showed it to you. It's kind of doesn't make sense that I ask you again. In the startup method, we have to add an appropriate line. And I think you get the idea. I word comparer, word comparer. If somebody needs a word comparer, here you have the word comparer. Get it? Good, I've done that one. Now we need to make some final adjustments to our spell check controller. What do we have to change? How do we get our I word comparer?
Add the interface to the constructor.
I agree. I word comparer, save it for later use. So I'm not sure if Visual Studio can do that automatically. Yes. You see? Yeah, it does it with a property. This is the right one. You see? If I just add it here to the constructor and I don't do anything special, Control dot, create and initialize field comparer, bang, and it automatically adds the assignment and adds the read-only field. Again, saves you a lot of typing. Good? And then down there, we can use the comparer. Correct? And what does Visual Studio tell us? Hey Rainer, you are no longer using the logger. Just like before, can remember the pizzeria with bringing your own salt and bringing your own flour? Now we can really get rid of all the things that we are not really interested in. Because these are the things that other people care for or that other services care for. So let's get rid of the logger, let's remove the logger here, and let's remove the logger here. Yoo-hoo! Now it looks nice. So now let's take a look at the spell check controller. The spell check controller is now our user interface. The user interface consists of kind of, let's say, orchestration of the whole process of looking up a word. It reads the dictionary, it splits the dictionary and the sentence, it triggers the word comparison and returns the result. We could now go on and further with the same principle. We could, for instance, say, we would like, as you suggested, to extract the splitting of the dictionary. We could change the dictionary from a string array to something more complex and inject it. We could go on, but I think you got the principal idea, right? Every service gets its own class. For every service, we need an interface, and this interface and its implementation is then registered in dependency injection. Good? Good. One of the things that are still open is the thing with the transient stuff here. Yeah? Does anybody have an idea what transient could be, or what the opposite of transient would be? No. If I tell you that the opposite is add singleton, does that help? Not really, oh? Does it? Okay, good. Let me draw again. I will draw here on my screen, not on the blackboard, because then we have it on video. Imagine the following situation. We have a server here in the middle, and then we have some clients here, and here is a client, and here is a client. And all these clients, they send HTTP requests to your server, right? In the server, first question, our controller, the spell checker controller, how often does ASP.NET Core create a controller instance for us? Do we have a single controller, or do we have a controller per incoming web request? What do you think? The answer is you have one controller per web request. So you have one spell checker controller, you have a second spell checker controller, and you have a third spell checker controller. Now every instance of this spell checker controllers request, for instance, an iDictionary reader. An iDictionary reader. They say, hey, give me an iDictionary reader. And the question is, do they get their own dictionary reader for every single controller instance? Meaning something like this. One iDictionary reader, second iDictionary reader, third iDictionary reader. He gets one, he gets one, he gets one. Or will it be a little bit different? Will we have a single iDictionary reader that all controllers get? And this is what we are controlling here. If we say transient, that means that a dictionary reader and a word comparer is created for each controller. Every controller gets its own reader, its own word comparer. You know what I mean? Advantages, disadvantages? What would you say? Disadvantages? We have a lot of objects, right? Somebody has to clean up. C# has a garbage collector, so we are producing a lot of garbage, and somebody has to clean up after us. And that somebody, the garbage collector, has a lot of jobs. It takes a while to clean up after us. So therefore, yeah, we shouldn't create an unnecessary amount of objects. So if we don't need a separate word comparer for each controller, we shouldn't do that. The other thing would be, for instance, this one, a singleton. Singleton means, just to refresh your mind, we have one server, multiple requests coming in, we have multiple controllers, but this time we only have a single reader and everybody gets a pointer to the same reader. Get the idea? That would open up new possibilities. Think of a reader that does some caching. It reads the dictionary once and then only rereads the dictionary every 5 minutes, for instance. Then it makes sense that we have only a single reader and not a reader per controller, because then this single reader can store a cache. You know what I mean? And everybody can benefit from that cache. So in our case, it would make sense to add a singleton here. It's not a trivial decision whether you use a singleton or a transient. There is even a third option, which is called scoped. I will not talk about it because we have only limited time and it would be too complex for the moment. But if you want to read details, take a look at the dependency injection docs in ASP.NET Core. For me, it's important that you understand the differences between singletons and transients. If you understand that, I'm fine with that. So, we have an interface, we have worked everything through, let's give it a try. Let's run it. So I think we had spell check something, and yoo-hoo, it still works. Do you find this principle complicated, this dependency injection stuff? There are a lot of moving pieces. You have the class, you have the abstraction with the interface, you have the dependency injection, you have the constructors, and so on. So you have to get used to this logic. But the type of code that we write here is absolutely typical. It's typical for C#. Every modern C# ASP.NET Core application looks like that. And to be honest, if you take a look at other frameworks like Node.js or like Go frameworks, for instance, they all work in the same way. They all are based on abstractions using interfaces, implementations using classes, and dependency injections for wiring up the users and the offers for services. It always works the same. Good? Nice. Nice. So, please remember and store your solution. I'm not sure. I think I will check in the solution that I've created now, because we will now take a look at the upcoming homework, and you will see that you can use a bunch of things that we discussed today in your homework. Okay, so I will, after this lesson, take this simple spell checker exercise and check it into my GitHub repository, so everybody has a kind of template. Those of you who followed along on your own PC, you don't need my code. But maybe some of you haven't completely followed along, then it makes sense that I check it in. I hope that's okay for you. Good. So now let's take a look at the homework that I gave you. It's already in WebUntis, the link, so you should have it there. The other class told me that today GitHub isn't so fast, so it might take a few minutes until you get it, but no problem. I already have it in my C# repository. The homework is, come on GitHub, give me the link. Oh yeah, I think the Wi-Fi just broke. I am connected. Do you still have internet access? Yes. Why not me? No. I prefer my phone. Come on. Ha. Now it's back again. So I don't need my phone. Okay. So get rid of the phone. It was a temporary glitch. I wouldn't expect so many people surfing on the internet on our Wi-Fi at 4:35 in the afternoon, but
On Thursday.
on Thursday. Oh, I can't connect anymore. So just to make sure, I will take my phone. Connect. I'm sorry for the short interruption, but so good. And we are here. And we are here. So your job in the upcoming exercise is, I would like to have an anagram checker. Do you know what an anagram is? An anagram is a word that consists of the same letters that the original word, but in a different order. Listen, silent. Okay? So if we take a look, anagram animation, for instance, there are a lot of nice anagram animations online. Internet anagram server, yes, that is good. So for instance, if we say, generate animation, okay, listen equals to silent. Exactly. See, this is an anagram. So same letters, different order. It's also it's an advanced exercise to build something like that, but yeah, it's also very nice. So let's go. What should you do? you should implement various functions, but this time I would like you to implement two different user interfaces. One user interface is a command line tool, and one interface is the web API. I want you to write the logic once and build two different user interfaces. So what you need to do is you need to add the logic part into a separate class library. We have not created a class library in Visual Studio yet, but I'm pretty sure you will find out how that works. I added the link to the homework. It's really trivial. Right-click, project, add class library.NET Standard. That's it. Really simple. You will find it out. I'm pretty sure. Next one, functionality. The first functionality that I would like you to build is an anagram check functionality. I can specify two words, for instance, listen and silent, and then the anagram checker will tell me whether they are anagrams or not. This should be available as a console app like this, anagram checker, check, listen, silent, and it should say, yes, these two words are anagrams. And I want exactly the same as a web API. So, this is the perfect exercise for your upcoming exams. You will have to write a little bit of C# algorithm, a little bit of a class library, a little bit of a console app that's relevant for the C# exam, and you have to practice again building a web API with ASP.NET Core, and that's relevant for your mobile computing stuff. Good? All together in a single homework. If it is not an anagram, it should print, no, this is not an anagram, or in the web API space, it should return a bad request if two words are no anagrams. Talk and jump, they are no anagrams, obviously, and therefore bad request. This is the first one. The second one is a kind of replay of what we did today. But this time I would like you to recap what we did. So you should read a dictionary of anagrams from a file. This time the dictionary should look something like that. You don't absolutely need to write it like that. That's just test data, so you don't have to come up with arbitrary anagrams, just a little bit of helpful test data, I hope. Write it in a text file, and you have to read the anagram database from this text file. And please try to recap what we did today. So again, take from my sample the anagram database file reader. I think you get the idea. Just recap what we did today. You can simply copy the file, but I would find it more valuable if you try to build it on your own, and only if you are stuck, take a look at what we did today. Now, the functionality that you should implement is a get known. So you specify a word and you return all anagrams in the anagram database. So if I say get known silent, then you take a look in the database and you find out, oh, I have two anagrams, listen and inlets. Get it? But please remember, it should work in the other way around too. So if I specify listen, I would like to get silent back, of course.
Also inlets.
Huh? Also inlets. Sorry, yeah, of course. Yeah, I didn't mention that. Good. Yeah, the anagram checker prints it on the screen, and the web API returns it as an array. Pretty simple. The user interface is not the problem. Question?
If in the example words there is no anagram of listen and inlets, but only for listen to silent and silent to inlets, should we still check if the anagrams have other anagrams defined in the dictionary, or?
Yes.
Okay.
Yes, you should. I think it shouldn't be a problem because before you had to write a check algorithm, and therefore it shouldn't be a problem to find really all anagrams that are in the database. Get it? Yeah. You can also make assumptions. So if you make an assumption and say, I will only implement this in that case, please write a short comment in the code, and as long as these assumptions make somewhat sense, I'm fine with it. Okay? Good. So last but not least, do all the things that I told you. Use a C# interface, use dependency injection, use logging. Do you want to earn extra points? You can earn extra points. Add Serilog. We discussed that today in the morning with a file sync. that should be, I don't know, 10 minutes of work and you get an extra point. So that is really a cheap one. The last one is for those of you who like writing a little bit more code. I would like to have an algorithm that gives me all anagrams independent of whether they make sense. So in other words, give me all the permutations. That means I say get permutations of ABC and I will get all permutations that are valid for ABC. Okay?
Duplicates permutations allowed, for example, AABC, and that's...
No, that would not be an anagram. An anagram is the same number of letters.
Yeah, but if we enter AABC and get, for example, BAAC or BAAC with the two A's and switch.
Ah, I see. Okay, I don't care. Make an assumption. I don't care. Make an assumption. Now I understand. Okay, that is a second point. The second point might take you, I don't know, an additional few minutes to write the code. The first one is really cheap. So, yeah. My goal, why I give you this homework, okay? This homework is the perfect preparation for the upcoming exams. If you did the first homework, and if you do this homework, you probably have done 80% or 90% of the preparation that you need for the exams, okay? So it makes sense. It makes absolute sense, and I thought about how to put this together. It is a recap of what we did today, and it is a good step into the right direction for your exam. Good. So, any questions so far about what we did today? No? Good. Then I'm through with my with the topics for today. So feel free to already start to clone the repository of the anagram checker if you want to start already. That's fine with me too. I will use the last 5 or 10 minutes that we still have left to check in the example. And I think that's it. Okay? So thank you very much. I will put the recording of the lesson online as soon as possible. So if you want to refresh your memory with the things that I showed you today, it should be possible somewhere on the weekend. Good? Thank you, and that's it for today.